Yes, sirree. We are live. Wait, what? Well, yeah, I do remember I have really shitty upload speed. Might not work. Am I uploading? And we are live. Yes. Hmm. Sounds like a little echoish. But let's go. Okay. Hmm. Right. Wait. I think I changed it, no? Yep, super shitty internet. Okay. Right, so I started with a few problems just to see if I remembered anything. And I was able to solve a bit, I guess, around 40. So, I'm still doing easy problems just to get a hang of it. And maybe when I'm done with like 100, I think there's like 400 algorithms problems, 104, yeah, or more or less. I'm not gonna do all of them, I'm just gonna do the first few hundred and then, yep, let's see, okay. Given two things, they're isomorphic if the characters in S can be replaced to get T. Oh, oh. Which basically means the number of characters of oh, every E corresponds to A. Every G corresponds to D. Hmm. So off the top of my head, I'm thinking of map. Um. Their sizes don't match. Run falls for uh in S. Hmm. Now ignore the dirty spaces. This editor's shitty. I don't know why they don't let you auto format. It's so sad. I think it might be a premium thing. Never mind. Alright. If si dot if m dot find si, is equal to m dot end, which means if you don't find it, m dot insert si t I, and in case you do find it, then if m dot find si, I think you have to do dot second maybe. Second, no, I think that's the value. Oh no, it's a pointer. So second is not equal to ti, return false. So if you ever find pair that doesn't a key that exists, but the value is not what you find in the pair on the right side, then you fail it. Oops, almost. So, what? What? Okay, I don't know how to type m dot insert. So, yeah, of course I don't remember I don't remember the library anymore. So map, I guess you can just type map, insert, see an example, you insert as a pair, okay? So either create a pair, or I think this should work then, if it just needs a pair. Excellent. Sorry, ES, run code. Submit. This was easy. I'm thinking about another question. Ooh. What output true, expected false, B can be converted to B, A can be converted to A, D can be converted to B. Oh, we have to check the other way around as well. Huh. M1, M2. M1 dot insert this pair, and M2 dot insert. I mean, I don't know if it's a corner case, or maybe I just didn't think like that. If it is not equal to this, or m2 dot find, I'll change that, ti dot second is not equal to si, turn false. And then let's just run this case. Sure. Sure. Okay, what if, oh. Or if you've never found this key in this, I guess, or you've never found the other key in the other list. I think that makes more sense, doesn't it? Okay. Oh. if you've not find if you've not found what uh huh I just print I just use cout for debugging, obviously. I don't think you can debug this anyway. Oh, 0 1 2 3 0 1 2 0 1 0 1 2 3 for 2 it failed. Okay, of course. If I think I screwed up somewhere here. TI. No, this is fine. One dot insert. Two dot insert. If you haven't found this and you haven't found this. Okay, let's try to run this again. No, where it failed, this side or this side. So 0 1 and this happened. 0 1 and 2 this happened. So 2 printed. And this failed? What? Well, I cannot, for the love of God. Wonder. I think this might be an error, right? So one of them, you didn't find one of them, right? So if this happened is not equal to end, right? Then check for this. Return false. Else. What? I have no idea why this would go over here. Never mind, fuck it. No, it can't fuck it, bro. Else if this happens, that this exists, but this happens, then return. Oh, that's why. Oh my god. Okay. So if you found it in one, uh, so confused. So you come to DB. So if map D already exists, does it? No, it doesn't exist. So if mapping for B already exists, then if B second is, yeah, I think it should have come here, right? Cout m2 dot find si second. My bad. if you'd come to print B and A. That's so weird because these are two that shouldn't have been printed. Hmm. See out found SI. Didn't find SI. Hmm. Didn't find B, didn't find A. Oh, wait, what? Oh, for B it prints D. For A, B prints B, and for A it prints A. But it doesn't work. Why? Because for B, found B, right? So if found B, and if B dot second is not equal to SI, what is B dot second? And SI, so let's print that as well. I guess it wouldn't be else if, right? Okay, I'm pretty confident now with the solution, so that's why I'm submitting it. Yep, I guess this is the way to go. I wonder if somebody's done it without maps. One line but without hash maps, yeah. Okay, let's see if how to do it without hash maps. I think you could do it with like obviously character arrays, maybe. Maybe. I don't know. Can you? Maybe not. I don't know. Okay. Um. Let me see. Ah, no, that won't work. What I'm thinking is what you could do is find like the difference in each character, like e.g. Like ENA and then GND and GND. And then you have that array, which is the size, such size. You can see if then you can do another pass and see if nah. What you check is like for each character the number is the same. That is a kind of a map itself, I think. Okay. Yeah, some character array. Okay. What to say? If a if map of SI is not equal to map of TI, then return false. Map of SI is I plus 1 and map of TI is I plus 1. What? So some character they gives every character some value, some number, and if they don't match us, they're still using two lists. Um, yeah. I mean, it's sort of like maps, I guess. Yeah, it's the same thing. Yeah, so I guess we're good. Ah, AMS. I guess it's okay. I guess. Okay, reverse a linked list. Ooh. Oof, it's always been a tough one. I keep forgetting. And what did we learn? The new head. Hmm. Hmm. I think I've done this like a million times. I even drew it on a whiteboard last time, but I don't know if. Okay, so what it goes something like this, yeah. Um, so you have a few pointers. List node star. You have next, and you have previous. Um, and initially, previous is null, as you can tell. Hmm. And next equals head next. Now let's add base conditions. If not head, turn head. If or head next is null. Yeah, okay. So while head, let's say. I don't know what's gonna go there. Let's just see. So what we want to do is store what's next. So next is head next. Make the head point to the previous guy. Head next is previous because we already stored next. We're okay with resetting it. We don't do this here. And now the next guy. So we have one. So we've stored what 2 is. 2 is uh, wait, what? Okay, so we've stored what 2 is. One's pointing to null now. Now I think we should tell what the previous guy is, the new previous, because you've set previous. We used previous, so previous is now head. So next time, next is going to be head dot next, which is going to be 3. So right now, I don't know, do I draw it? I don't know. Oh, Microsoft Micro. Oh, for anyone who's wondering, I now work at Microsoft. Whiteboard. Download, no. Online. Sign in. Probably am signed in. Just return, I don't know, head. Yeah, so while, so now previous is head. Oh, we're now moving head though, right? Um, right now we have next pointing at 3. We need, um, next is head dot next. Head dot next is previous. Previous is this. Head is next, I guess. maybe. Output is null. Hmm. Um. Oh, because we're doing while head. So previous, like the last thing we reverted, I guess. That makes sense. Um. Let's just take a small array. That always makes sense. Check and just check null as well. I mean, it should be the same thing. So this is iterative. You could do recursive as well. I think uh, um, both of them are just as good. Um, hmm. Oh, okay, never mind. Whoa, what's this? Anyway, yeah. So I wanted to just draw quickly how these four lines are working, right? I want to just copy paste this text. Can I have some text here? Oh wow, great. That is just great. Okay, so this is what's happening, right? So we have a 1 pointing to 2. I mean, text is going to be better. Can I undo? I can't undo. Wow. Excuse me. Oops. Wait, I can't. Okay, never mind. Wait, what? 1, 2, 3, 4. That's enough. Never mind. Just, oh my god. Okay. Can I move this? Yep. Can I move this? And where is the eraser? Why cannot I erase something? Control X. Oh. Whoa. Okay then, I guess. Next level shit, bro. Okay. Yeah. Okay. So over here we had something else, which was called previous, and we set it to null. Right? Okay. So we have a previous variable set to null. Previous is null. So what we're doing is we're like preserving some state and then just resetting what we're currently looking at. So we're currently looking at head. So we store what's next to head here. So we stored this guy. So now we don't need this link. So we reset this link for one to point at the previous guy, whatever previous was. In this case, it's null, right? Uh, now, uh, now since we've used previous, like we, we've already used previous to get pointed at, we need to set the new previous for the next iteration. So now we set previous to 1. So now previous points to this. This is like initially head, but whatever. Now previous points to this. Now we need to do the whole thing again with the new head. And what's it gonna be? It was the next number that we stored in next. So now this is head. So if you see what happened, it's like say this didn't exist, right? This was the entire thing only. So it's like we had some previous, that case was null, now it's gonna be 1. And we had a head pointing at the starting of the linked list. And we just reverted this guy, let's say. And previous was the one who's pointing at the reverted linked list. So let's just revert this and see what happens. I think it's gonna make things like perfectly clear. So you have head pointing. So you store the next guy. So which is 3 head dot next. Since 2 set right now. So this is next. Then you said head dot next is previous. So now you don't need this link. So now you said head dot next to previous. So previous is 1, 2. Now who's pointing at 1? So as you can see, this part of the list is already reversed. And now I said previous to the head, since you've already used head. So previous now points to 2. And head equals next, which means now you have to start the iteration with the next guy. So now this head points to this. So the same thing happens. This point starts pointing at this starts pointing at this, and when you get here, you're like, okay, I'm done. And the last iteration is you can see after every iteration ends, previous points to the last head. This is going to be the last head that we process because when head we go to the next head, we null. So previous is going to point to 5, so that's why we return previous in the end. Yeah, that was a quick drawing. Can I clear everything? I don't want to waste your time, so I don't want to go and check this, but it's fine. Wee. Okay, I have no idea what this is. Anyway, right. Reverse a linked list. Oh, I was wondering what 4MS solutions are, and it's literally the same code. It's actually like the server executes a little differently in both cases. So that's why sometimes there's small difference. Oh, what is this? Super complex code. It looks like it's the same code. Pretty much looks like it's the same code, but yeah, never mind. It's just a whatever. Okay, given an array of integers, find if the array contains any duplicates. Your function should return true if any value appears at least twice in the array, and should return false if every element is distinct. Huh. So I don't know if maths works here, if NAND works here. It's not a very highly avoided question. It's probably not maths. If it were maths, maybe it'd be different. So a bunch of ways, I guess. Um, Obviously, keep a map. If you find it in the map again, it's over. A poor way is sort, check consecutive numbers if they're the same. So it's and log n anyway. Or like n square. It's just check every number with every other number. Let's see if there's any hint in the question. Given an array of integers, so it could be negatives as well. Find an array. Find if the array contains duplicates. So like I'm just thinking of the techniques that we know. So for arrays we know stuff like double pointers, two pointers, sliding window, sorting, um, index arrays, maps, uh, somewhat stacks, but I don't see how that fits here anyway. Um, I guess that's it. So map looks like a pretty straightforward thing. So let's see if I don't know if there's just a key map. Okay, for int n in nums, if m dot find n equal to m dot end, m dot insert n true, else return false, return true. Find that. So yup, I guess that's pretty much it. And it is going to not work. Whoa. Output is false, expected is true. Find if it contains duplicates, then you have to return true. So I'm stupid and submit. So it's an open question, I guess. Whoa, that's slow, I guess. Still kind of slow. Let's see. Uh, Linear search. That's n square. Then it is sorting. It is n log n. Then it is hash table, which is accepted. I mean, I don't know. Ah, that's actually a good thing. Like you don't write an else and instead, wait, what's this? What's this? Okay, never mind. And then this you can just write there. I think I might have, no? Okay, that's good. I think, yeah, I did switch it, so it's the same thing. Okay, yeah, so I guess that's it. Contains duplicate 2, stack using cubes, invert binary tree. Okay. Um, contains duplicate number 2. Oh, it's a shitty question people are saying, but let's see. Given an array of integers and an integer k, find out whether there are two distinct indices I and j in the array such that this and the absolute difference between I and j is at most k. Integers, whether you have to find two numbers that are the same and the difference between I and j is less than k. Difference, oh, 0, 1, 2, 3, 0, 1, 2. I mean, if you check every number with every number, this, I mean, I don't know, yeah, just this shitty n square question is what it looks like. Or, or, it could be a map question. You could store all the values in the map. And every time you find it, you update the map with the newest index because you don't care about the older index anyway because you're going to compare it with the new index because that's going to be closer and that could give you an answer if there's any pair. So you don't care about non-pairs anyway, negative cases. I'm kind of using memory as well because I think I remember a map solution to this question as well. So I'm sort of cheating, but okay. So for a int I equals 0, I is less than nums dot size I plus plus. If nums dot if m dot find sorry, don't ask me. If m dot find nums I is equal to m dot end, so if you don't find the number, dot insert, you insert the number nums nums I with the value key, the index. Else, if you do find the number, then m dot find nums I second if this number is less than or equal to k minus I abs, I guess, absolute value of this is less than equal to k, return true, else m dot insert, I guess the same thing, end home, end home paste. And if nothing works, return false. And okay, I wanted to run all the cases actually. What? That's good. Okay. Ooh, okay. I get it. True, true, false, true. So, wait, true, true, false, false, true, true, false, okay. For some case it said false, right? Which case was that? Second case. Which was, okay, so, I don't know, let's see if the insert is giving some kind of an issue. So, I asked if the index, if you find it, you don't even need to do abs, I guess. Oh, find, yeah, I minus this is just straight up the way to go. And false, false, true, true, false. If there way to resize this? No. Great. So 1 0. See out I, right? Every time you insert, just let me know. I just want to check the other case, which is 1 0 1 1 1 1 code. So I get 0 1 2 and 3. It already exists. And I is 2 and 3, and m dot find m dot erase m dot find nums I. It's gonna be slow, but it's fine, I guess. Run code, and it should all be fixed now. Submit. Drumroll. And it's okay. I don't know why it was a shitty question, but with unordered set. Ah, set. Set might be the thing that I'm looking for. Sort of map. Ah. Set is a store that can store unique elements in a specific order. Right. Set is what I was looking for. Yeah, so don't use map, use set, because you're not using value. When you're not using value. But wait, what? With set? Ah, wait, what? Wait, what? I is greater than k, erase. Ah. Oh, you can just like reset it like this. Ah, if it exists, you can reset. Hmm. So let me see. M nums I equals I. Should be a little less, maybe. Oh, all good. Anyway, implement a stack using only two queues. The stack should support all functions of a normal queue. You must only use standard operations of a queue. Depending on your language, the queue may not be supported natively. Okay, whatever. Two queues. To make a stack with two queues? What? Okay, so a queue is first in, first out. And a stack is first in, last out. So let's say you push to the stack, you push to a queue, then you push to stack again. If you push to a queue, and push. When you pop, you need to take out the first element. So when you pop the entire queue into another queue, into the second queue, and then just take the last element and not pop it. Leave size, yeah. You don't pop, you don't push it to the other queue, you just pop it and you return it, and you will set the first queue back to what the second queue is right now. So, and how do you get top? Top is the top element of the stack, which is the last element that you pushed. So I guess you have to just maintain top at all times. Okay. Okay. So we're gonna have QUUE of integers, I guess. That's usually T that you pass the type. Support a type. So you have primary queue and secondary queue. Remember the stack is empty. So if the primary queue return primary queue dot empty. Okay. When you push. So when you push into the primary queue dot push x, and I think you have a variable called top. I hope top's not called the wrong times. Top equals x. And then when you're popping, so while primary queue dot size is greater than or equal to is greater than 1, uh, int f equals primary queue dot front, secondary queue dot push front, and primary queue dot pop. So you move one element from primary queue to the secondary queue till you've just one element, top equals primary q dot front, and then primary q dot pop, and then primary q equals secondary q, and secondary q is dot clear, I guess. I don't know. Is that a clear q? I hope so. And that should return top. I guess I can just name it T to avoid confusion between the function. Okay. Dot clear is not a. Let's see. C++. QUUUE. And maybe create a MTQ and yeah, I guess makes sense to QUUE. Let's do this while second q dot empty home q dot pop, right? It's okay. Yeet. What? Oh, what? Top okay, return T, I guess. I mean, I don't know. Looks like this should be it, but could be an issue. Okay, push 1, push 2, pop 2, pop should be 1. Okay, let's see. Pushed 1, push 2, and pop 2. So when you push, you're just pushing to the Q, saying top is 1, then top is 2. Okay, top is 2. And when you pop, while its size is greater than 2, it's 1. It's 2 right now, so the front is 1. You push 1 to the secondary Q, and you pop 1. So now it just has 2. So T is 1. And then sorry. Oh, here debugger premium. Okay. Standard output is 2. Primary Q dot front. See out pop. Huh. First and last out, right? So primary Q should be oh, wait, what? Wait a minute. No, yeah. So should be 1 that's moved out. C out F. My bad. C out F. My net crashed. Yeah, so F is 1, right? So now when you pop PQ.pop, why does it? Okay, let me let me make a pretty bad assumption, yeah? I don't know, constructor, let's see. Nah, that's a pretty bad assumption. Let's see PQ dot size, yeah? What's this? Ah, I mean, it's 2. Obviously, it runs once. How is PQ dot front T? Oh, you pushed 1, then you pushed 2, then... Oh, wait a second. That's not gonna be top. Oh, my bad. Um... Oh, okay, so it's actually 2 when 2 elements are left. Oh my god. Hmm. Actually, this could be the answer. T is equal to PQ dot front. So it happens till you keep hopping and then you have just 1 element left. And then you don't have to pop. When you have just that 1 element left, why do you even care to pop? Um, yeah, that makes sense. Output is 1, 1, expect to 1. Okay, so you push. What? Okay, push. When you pop, hey, shut up. Pop, it should return, um, the element just pop. Turn T. Oh, so you do have to set T equals to PQ dot front. That's weird. Uh, oh, just doesn't matter actually. This is the element that I just popped. That's the issue with the code, I think. That wouldn't would it matter? Yeah, would have mattered. The last digit was getting kind of changed, so you don't want to do that for sure before. Yep. Yeah, so I think that was pretty clear. So you have 2 queues. That's a shitty drawing. Um, so you have basically 2 queues. So you push in one, push everything. This is P1, this is P2. Why P? It's a queue. Q1 and Q2 when you push everything. So this is the first element that was pushed, and this is the last element that was pushed. So queues are first in, first out, but you want first in, last out. So what you want is you want to preserve all of this. You want this to go away. So you can get all of this before getting to this, obviously, because it's a queue, so you can get the first element. So you take this first element and you push it here. So let's number these for clarity, 4, 5. So you pop this, you get 1 here, and you push into this. You get pop 2, and you push 2 into this. You pop, push, pop, push. And then now this only has 5. So this is what you're popping, right? So you return this. And how do you set the top? Before you, like before every pop, basically, what I'm doing it, what I'm doing is before every pop, you just say, okay, now this is the top, now this is the top. Now what is actually going to be the top is the last number that gets popped from this before this, which is 4. So this automatically sets this as to be the new top, which we want because we want the last element that's pushed to be the top. Like in a stack, it'd be like 1, 2, 3, 4, 5. When this is popped, this 5 is popped, we want this to be the top. So we're just setting it while iterating. It doesn't matter. You could like do it any other way, but that's how I'm doing it. So now just reset this, set this to this, and uh, like make this point to this. Not really. Like set all the elements of this to this. So you could pretty much like swap, call swap on Q2 and 1, or if you remove this as well, or you could just set all the elements of Q1 to Q2 as Q2 and then empty Q2, like by popping all of the elements in Q2 like this. I don't know if this makes a point. I don't think it points because these are not pointers, I guess. Right? I don't know shit. Right, invert a binary tree. I don't even know. One sec. Screen went black. Okay, invert a binary tree. Google 90% of engineers use the software you wrote, Homebrew, but you can't invert a binary tree on a whiteboard. So okay, we'll see what that is. Looks interesting. So basically, to flip every node, every left to right, and so on and so forth. So let's just go for it. So what you want to do, if it's null, then just return null, right? I don't care. Otherwise, what you want to do is we can have a temp if you want. Um, let's have a tree node start temp, which is say the root dot left. Doesn't matter if it's null. We just set root dot left as root dot right, and root dot right is the temp. So we just swap them, and then we just invert root left and invert root right. I mean, I'm pretty sure this is how I would do it on the whiteboard as well. So that's pretty much it, I think. Uh, what else? I think that makes sense to me. So submit, I guess. I mean, might miss some corner case. I don't know. So 4ms is just it could be 0ms the next time I run it. So yeah, pretty much. Recursive accepted, iterative accepted. I mean, why would you do this? This is like so straightforward. What's right? Oh, yeah. Oh, that also works. That freaking works, bro. That works. Right. Uh, Google 90% of our engineers use the software you homebrew. Okay. Okay. Alright, sorry. I don't know. Sorry. Okay. Summary ranges power of 2. Okay. Am I still streaming? Click here to retry. Let me just check if I'm still streaming. Yes, I am. Ooh, ooh, ooh. Oh yeah. Okay. Yes, I am. Oh yeah, about a 10-second delay, I guess. Okay. Okay, next question. Yes, I am. Oh yeah, about a 10-second delay, I guess. Okay. Okay, next question. Yes, I am. Oh yeah, about a 10-second delay, I guess. Okay. Okay, next question. Yes, I am. Oh yeah, about a 10-second delay, I guess. Okay. Okay, next question. Yes, I am. Oh yeah, about a 10-second delay, I guess. Okay. Okay, next question. Yes, I am. Oh yeah, about a 10-second delay, I guess. Okay. Okay, next question. Yes, I am. Yes, because तुम मेरी बात नहीं सुनती हो. That's why you're getting ignored. No, shut up. Yes, because तुम मेरी बात नहीं सुनती हो. That's why you're getting ignored. No, shut up. Yes, because तुम मेरी बात नहीं सुनती हो. That's why you're getting ignored. No, shut up. Yes, because तुम मेरी बात नहीं सुनती हो. That's why you're getting ignored. No, shut up. Yes, because तुम मेरी बात नहीं सुनती हो. That's why you're getting ignored. No, shut up. Yes, because तुम मेरी बात नहीं सुनती हो. That's why you're getting ignored. No, shut up. Yes, because तुम मेरी बात नहीं सुनती हो. That's why you're getting ignored. No, shut up. Yes, because तुम मेरी बात नहीं सुनती हो. Yes, because तुम मेरी बात नहीं सुनती हो. Yes. Hmm. Hmm. if um hmm if hmm hmm if hmm change कर लें plus 1 and equal to nums I. Okay, change कर लें okay, plus 1 and equal to nums I. ठीक. Okay, change कर लें okay, plus 1 no equal to no I. ठीक. Okay, Bluetooth no earphones no ठीक. Bluetooth okay earphones ठीक. Bluetooth okay earphones okay 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 okay. Can you concat strings C++? Okay. Can you I guess you can just do it like this. That's good. Hmm. I'm still streaming, Oshin, so please wait. I guess you can just return red val. Okay. Hmm. I'm still streaming. Oshin, run. So please wait. Is that all? Return red val. Okay. No member name push to. Oh. Is that all? Hmm. No member name push to. Oh. Is that all? Hmm. No member name push to. Oh. Is that all? To string. No member name push to. Oh. To string. Int to string C++. If I control enter it, but it's okay. Int to string. Bring it here. What is this? Convert number to string. But it's okay. Int to string. The str. What is this? Convert number to string. Okay, let's just try. Dot str works. What is this? Convert number to string. Okay, let's just try. Dot str works. Huh? No member named push in. Huh? अरे यार, underscore no back. Member named push in. Huh? अरे यार, underscore no back. Member named push. Huh? In. Huh? Plus. Sir plus no member. No matching member function to call pushback. Oh. Sir plus no member. No matching member function to call pushback. Oh. Sir plus no member. Oh. Output is.
Oh,
Output is.
wait, what?
I didn't reset anything here. If nums I is equal
Wait,
to
what?
else, start is equal
I
to
didn't reset anything
nums
here.
I and equal to
If
nums
I
I.
is equal to else,
Start is
I
equal to
didn't reset anything
nums
here.
I and equal
If
to nums I.
boo, what is this?
Else start is equal to
Index
nums I
4 out of bounds for type.
and equal to nums I.
Boo, what is this?
Start is equal to
Index 4 out of
I
bounds for type.
and equal to nums I.
Boo, what is this? Index 4 out of bounds for type. Index 4 out of bounds for type. Not much, yeah. I mean, I've solved it, just some nitty gritty is left. Not much, yeah. I mean, I've solved it, just some
Oh,
nitty gritty is
almost.
left. Um, Execute. Oh, almost. If nums, um, execute. Oh, almost. If nums, um, execute. Oh, almost. If nums, um, verify. If nums, this will be buggy, I think. Verify. Wait, what? This will be buggy, I think. Verify. Wait, what? This will be buggy. This makes sense as well. Wait, what? Because the last set is never pushed. This makes sense as well. Last. Oh, so cool you are. The last set is never. If nums dot size is 0, last return. So cool you are. The last set is never. If nums dot size is 0, last return. So cool you are. The last set is never. If it's reject. Nums dot size is accepted. 0, woohoo. Okay. So this is, I don't know, is this well uploaded? This is average question. Reject. Anyway, okay, I have to go to sleep. Accepted. Woohoo. Okay. Bye so bye. I don't know, is this well uploaded? This is average question. Reject. Anyway, okay, I have